Hello, here's another AQA A-level multi-choice question on refraction and diffraction. If you'd rather do a different question on the same topic, click on the information bar up here and that'll take you to the playlist. If you want to do this question yourself, pause the video now. If you got the answer D, well done. So, a monochromatic light wave travels from glass into air, so it's travelling from a more optically dense media into a less optically dense media. So its velocity is going to increase. Its velocity is definitely, or its speed will increase. Which row shows what happens to the wavelength, speed and photon energy? Well, let's look at the speed. We're looking for an increase option. What about the wavelength? Well, from your data sheet, the speed of a wavelength is equal to its frequency multiplied by its wavelength. The wavelength is equal to the speed over the frequency. Now, the frequency of a wave doesn't change. If the frequency of the wave doesn't change but its velocity increases, then the wavelength must also increase. So we're looking for an increase in wavelength. Finally, the photon energy. Again, from your data sheets, the energy of a photon of light is given by the Planck constant multiplied by its frequency. So the higher the frequency, the greater the energy. But I've just said the frequency doesn't change on a photon. Whatever the media it's in, the frequency remains the same. Therefore, the energy of the photon does not change. So, we're looking at line D as the only one which gives all three correct statements. If you found this video useful, please hit that subscribe button for me, watch some more in the series, share with friends and press the like button if you like. Thank you very much.